Greetings and welcome to Talk a Little, Learn a Lot, the American Society of Naval Engineers podcast. I am your host, Stephen Phillips. In this podcast, we talk a little and learn a lot about naval engineering while inspiring the next generation of STEM professionals. Today, I'm joined by Captain Rick White, U.S. Navy retired, to discuss ASNI's Technology, Systems, and Ships Symposium, scheduled for November 17th and 18th at George Mason University. All of the details about this event are on the ASNI website, so I recommend that you check that out there. Rick, thank you for joining the podcast. I look forward to our discussion.
Same here, and thanks for the invitation.
Rick, how about if we start? Would you please introduce yourself to the Talk a Little, Learn a Lot audience, please?
Sure. First of all, I'm a 1977 graduate from the Naval Academy. I've got a bachelor's in naval architecture. I spent 5 years as a surface warfare officer on the USS Fidelity, a minesweeper that was commissioned before I was born. Then I got a chance to commission the USS Arkansas, a nuclear cruiser. I got a chance to go to graduate school where I picked up degrees in both mechanical and systems engineering. I transferred to engineering duty, and then I had tours in Dahlgren, Wallops Island. I was commanding officer, 2 tours at the Naval Academy, a program manager for the amphibs, auxiliaries, and command ships. And then I was also the system engineer for the ballistic missile defense program. And finally, I got a chance to conclude my tour, or conclude my career, if you will. I was Dean of Engineering at the Naval Academy. So it was a great way to wrap up my my career.
Wow, what a rewarding career in the Navy. Very cool. The TSS theme is Forged to Fight, Past, Present, and Future. From your perspective, what major lessons from naval ship design or operations of the past still hold true, and which have been sort of overturned or overcome by modern technology or new mission demands?
You know, I'm going to start, Steve, with a loaded comment. All of your questions beg, in my mind, what's going on in the Navy right now. We have been infatuated with minimal ship manning. We've been infatuated with let's get technology out that's not quite ready. And I think the surface Navy specifically has suffered from that. In my mind, sailor training is a must, both operator and maintainer. We've kind of forgotten that skill. Excuse me, I never lost the Navy piece, but the Navy, I think, has lost a little bit of that. The Navy has become reliant on off-ship assets, which may not be as timely or responsive as necessary. You know, we've all heard the stories of baling wire and chewing gum and duct tape. I think we've lost a lot of that. Keep the ships running. Sailors are wonderful people. We have to train them. We have to give them the knowledge and skill sets to repair on the fly. In the technology world, I think we're seeing an influx of AI, artificial intelligence, and machine learning. Um, there's good and bad in that. Building or manufacturing parts in real time it has the potential for significant maintenance impact savings, but doesn't necessarily represent the solution to hands-on training, maintenance, and operator efficiency. You can't gun deck it. Sailors have to understand their systems. Operators have to understand their systems and need to know how to react when they don't operate as designed. Over.
Yeah, indeed. Now, one of the focus areas for the event is digital transformation to facilitate more players on the field. So, what do you see as the major barriers to enabling this vision in shipbuilding programs?
Again, Steve, this is a great question. In my experience, there's a couple of huge challenges. First of all, you've got operational priorities that take ships out of maintenance periods. Then you've got budget priorities, which also play a significant role. From an industry perspective, How do you procure material if you don't know the sustained workload? That's a challenge. And acquisition requirements. I was an acquisition guy. I was a ACAT 1 program manager, but they're a pain in the fanny. Um, how do you transfer technology? How do you get it to the warfighter? How do you do it in real time? The acquisition system is slow. Um, Part of that is good, part of that is bad, in my opinion. Um, and also, you've got the congressional priorities, which also play into this. Um, from a day-to-day perspective, workforce challenges are real. We got them both in blue collar and white collar. Um, the incentives, to attend technology schools from high school, um, it's growing, but it's not where we need to be. We've got several generations of people that have graduated, have learned, got to have a college degree, got to have a college degree, but it doesn't teach you to do anything. Where do we grow the next set of ship fitters, the next set of electricians, the next set of pipe fitters? That is a real challenge. And I believe that not just shipbuilding, but all the industries, maintenance, as well as the United States technical support are suffering because of that. We've had a degradation of the government. And the other part is government acquiesced a lot of the technical authority to industry. And then the technical competence of the government has declined. We're trying to grow back from that. It's going to take a while, but it's a challenge. Over.
In your view, which technologies or system integrations like electric and hybrid propulsion systems or unmanned ship technologies, autonomous systems, what of all of these holds the greatest promise and maybe even what has the greatest risk for disrupting naval platforms in the next decade?
Well, the simple answer is we got to have it. you know, um, we need um, we need to have more power on the ships. Um, the speed of light weapons are the next generation. If you're looking at intercepting a bullet with a bullet, you got to have a 3-to-1 time constant advantage. We don't really have that. So speed of light is a requirement, in my opinion. But in order to do that, you got to have a weapons magazine that can help you, which requires electric propulsion, electric storage. The battery technology, the ship safety technology isn't quite there. Um, the, the other problem that I see is an acquisition risk. What what PM or PEO will take the time or take the step on the windy corner to introduce a new technology that's outside the box of the acquisition baseline? That is a real problem. We're not the PMs are not funded to do that. If you step outside, you got to go get permission from everybody to do it. So the transformation of technology to warfighter, we call it the Valley of Death, is a huge problem. And it goes across from training, from maintenance to technology to capability. Um, that is a significant challenge in today's acquisition program. You just can't do it. And I think the warfighter ends up suffering in the long run because you just can't get something to them in real time. I right now am a consultant to several small businesses, each of whom have technologies that I believe the warfighter would significantly help the warfighter. You just can't get there from here. Um, the POM process, the budget process is moves at a snail's pace. So that's a challenge. Over.
Rick, systems engineering is always a challenge in integrating the subsystems, the sensors, the weapons, platforms. Based on your experience, what are the best practices or perhaps cautionary tales for managing complexity and ensuring reliability in large naval systems?
I'm going to go back to my Aegis heritage here. As a lieutenant, I grew up in Aegis project. Um, I was on the commissioning crew of the Arkansas non-Aegis platform
Was
when the
it
nuclear.
NTU,
No,
Arkansas?
it wasn't. No, it just had a mishmash of combat systems. When it came time to upgrade the weapon system to meet the threat, there was no system. There were multiple systems. So in order to upgrade that system, you basically had to slice off the main deck and move everything forward. So we look at Aegis, which was integrated. You got the eight elements of the Aegis combat weapon system, excuse me, and you add on the weapon system. And so the the fact that you had one program manager responsible for the total ship and lived by the baselines, kind of almost like we're talking here, build a little, test a little, learn a lot, um, was significant. And I think, although not in those terms, the submarine community follows the same premise. I'm not a submariner, so I can't speak to that, but I think there are significant lessons to be learned from the Aegis project. Not the fact that, oh, it costs a lot of money, but boil it down to the basics. What is it that Aegis did? What was it that Admiral Meyer um, required, and why did it work? And his bottom line was there's no excuse for systems engineering and no excuse for risk aversion. I like to call that synergistic antagonism, the push pull of the acquisition and the want versus need versus reality. Um, so the system engineering requirement, the need for total management of the hull, the HM&E system, the weapon system, the combat system is essential. Over.
This is when I'm obliged then, because you made that comment, to tell people, because not everybody in the audience might know that the title of this podcast, Talk a Little, uh, Learn a Lot, is based on uh, Admiral Wayne Meyer's mantra, build a little, test a little, learn a lot. So, yeah,
Yeah, I
this
should have
we
mentioned that, but thanks.
the life cycle from design through sustainment and modernization is central to TSS. How should ship programs evolve their sustainment and upgrade strategies from the very early design phase to minimize life cycle cost and maximize readiness?
That's again, that's a great question, and I got to hand it to you. You kind of pinged on a number of questions that really, how do I say, light my fire.
Thank you.
I, I lived in these worlds. This one, from a life cycle perspective, if I was a life cycle program manager, so I had everything that was big, fat, slow, and gray. Um, as a shipbuilding program manager, there are goals and objectives for life cycle costs, but there are no um, metrics. There are no key performance parameters. So how do I, as a lifecycle program manager, accept a ship or ship class without the requirements from the shipbuilding program manager that says, yep, I'm going to meet these? That's a huge challenge. I don't know how to solve that one, by the way. I don't know if the Navy has ever solved that one. But again, I'm going to go back to the system. What is the requirement of the system? I got a system that says you got to, you know, you know, jump this high and move this fast in shipbuilding. But as a life cycle program manager, what is that jump high, move this fast requirement 20 years down the road? And how do I manage that? Part of it is modernization. I may or may not control all the modernization requirements as a lifecycle program manager. The fleet certainly has a a say in that from a maintenance requirement. And those piece parts, the maintainability, the operational capability, the modernization capability, are not as fully integrated from a system perspective as we might want to be, what might want to think. Each one has their own specific requirements, their own specific objectives, and they compete. They compete for dollars, they compete for time, and it sometimes puts them at odds with one another. It's a challenge.
We talked about this a little bit earlier when you were mentioning that, you know, most young people have this idea of they want to go to college and they don't think of the trades. I know that workforce development is a priority at TSS. What skills, mindsets, or institutional changes do you think are critical in order to prepare that next generation of naval engineers, technologists, and system integrators?
Again, I'm going to sound like the what do I want to say, that I'm blowing smoke. This is another great question. At TSS, we've really tried to um, focus on our young professionals. We have a separate panel. And what we discovered is the next generation of folks, they think differently. They're not, you read the magazine Gen Z, Gen X, and I am not an expert. I do believe that. But we have to recognize the fact that young people today think differently. They communicate differently, but they're just as smart. In fact, they're smarter than we were. And I think there are two parts to that: blue collar, white collar. In the DC area, it's basically a white collar world. The folks are looking for the next generation design engineer, next generation accounting engineer, and I'm going to use that engineer word a lot. On the waterfront, it's the maintainers, the wrench turners, the ship fitters, the electricians. Where do they come from? How do you get them engaged? Um, and I think it's critical to find out how to deal with the mindset of the younger people. We've got several young people helping us in at the TSS symposium coming up to talk about that, because us old farts, excuse my expression, older people, we need to understand how they think. We need to figure out how they work, and then not necessarily change everything to their perspective, but at least understand their perspective and then integrate it with ours so that we can move forward. It's a real challenge. I think personal opinion here, we've created a culture of got to have a degree, got to have a degree, got to have a degree, but I'm not sure all those degrees are sellable. All those degrees are capable, and we need technical technical degrees, people that are technical in technology, the blue collar people, and white collar, to help move us forward. We cannot sustain an economy in the service industry, so we need to move that. We need to help facilitate in moving that forward. Over.
Rick, in the context of lessons learned, what program or ship class, either past or ongoing, I guess in your case from the past, do you use as a case study when teaching systems or ship integration or ship modernization?
I talked about this a little earlier. I think the Aegis project is a case study for the surface world, in terms of, we're just going to step on the windy corner, how to do it right. You had single authority. You had a single program office in OpNav. You had a single program office in the systems command with total accountability on how to deliver the ship. The ship was the system, from the hull to the HM&E to the weapon system to the combat system. And I think that baseline, it should be, um, in my opinion, it should be and is a model for the future. I think we've had the Navy, excuse me, has had a number of false starts, a number of challenges. I'm not going to mention anything specifically. I think everybody knows what they are, but you need to have somebody in charge that can manage the development, integration, and introduction of capability. And that has the budgetary, that has the authority, that has the acquisition responsibility to deliver the system. And the system is a ship, not a weapon, not a radar, not a hull, but it's a ship. And that's what the fleet needs. Over.
Rick, the symposium encourages contributions from government, industry, and academia. From your vantage, how can these sectors better synchronize their efforts, especially in research and development and in prototyping, to accelerate transition of naval ship technologies into fleet use?
I touched on this earlier, but there is a great chasm between R&D, prototyping, and fleet introduction and operational use. I think the valley of death, as I call it, is something that requires the attention of all parties. Industry likes to sell the latest shiny, brandy new widget. The program managers are looking for the maximum capability for the least amount of cost. The budgeteers, acquisition folks in the Pentagon are saying, F, you only got $1. That's all you got to spend. And the operators kind of go, no, we need something different because there's something we can't handle here. And so those entities tend to be at odds with one another. They pull against one another. The Navy doesn't necessarily bring them all into the same room at the same time to chat about that. So I think it's paramount on all parties to come to the table and figure out how best to address that. The fleet says, "Hey, I got a priority and a high need," so they flashbang something through the 4-star community up to the Pentagon. May or may not get funded, may or may not get introduced, but it's not going to be sustainable because it's not a program of record. The R&D community says, "I got a widget; it can solve your problems." So they work through the SBIR world, up through the R&D folks, and it dies on a vine because it doesn't get funded for the life cycle. The program manager says, it's risky. I got to go outside the baseline. So those communities need to come together more often, and communicate better and figure out how to change the priorities. There's always a challenge is what's wanted versus what is needed versus what can be afforded. And it's, like I said earlier, it's synergistic antagonism. Somehow the Navy needs to figure out how to get capability into the hands of the warfighter outside their POM cycle and not have a 5 to 7 year delay cycle, just because that's the way the system operates. Over.
TSS is focused in part on unmanned ship technology. What do you believe are the critical enabling technologies or integration challenges that have to be overcome to field unmanned surface and unmanned undersea platforms at scale?
I think the unmanned world is a game changer, but I think there are several challenges that have to be overcome. First of all, how to effectively communicate between the unmanned vessel and the controlling operator. Maybe not controlling operator, but to make sure you have situational awareness.
There's
How do you
some
make
human
sure
in the
that,
loop at some point, right?
yeah, I think you're right. Everything relies on GPS, but we all know that GPS can be spoofed. So how do you mitigate that? How do you validate an unmanned vessel to fire a weapon? Closing the fire loop, closing the weapons loop is a significant challenge even for a manned vessel. But how do you do that with an unmanned vessel? Um, so there's an operational piece to this. There's a strategic piece. How does the Navy put these in a position to garner intelligence, to report back? Uh, but again, I believe they're game changers. First of all, maybe you don't have to follow all of the ship construction, the mil spec world to put these things at sea. So maybe smaller yards, maybe smaller design criteria can be used to get more of them out there for any number of operational requirements. Um, how do you manage them as a system? Again, I'm going to come back to that system world. Um, how do you maintain a fleet of unmanned folks? I don't know the answer, but I do believe that their autonomy, their survivability, all of the things that you mentioned are game changing. And I think the Navy is spot on in moving them forward. Or
Now let's talk about the future part of the theme for the event. What emerging technology or system architecture, even one that might be speculative, do you think has the potential to become a game changer for naval platforms 20 years from now?
I think there's a couple of them. First of all, I think you have to recognize the Navy's going to have to develop what I'll call speed of light interceptors. The inbound hypersonic that maneuvers it is in fact a real challenge. Can you intercept it with a hit to kill weapon? The inbound guys got the time constant advantage over the interceptor. So I got to have speed of light. I think that's a requirement, which then drives energy magazine, which drives the capability of the hull to provide it, et cetera, et cetera. I also think there needs to be a significant improvement in both the development and maintenance systems so that the two can move quicker. We can't wait. The Navy can't wait 5 to 7 years to develop and get something new into the hands of the operator. And the other part of this is, and I think the LCS was a start, platform flexibility, not platform. Admiral Meyer would kill me. Ship flexibility. Platforms are oil derricks. Ships are at sea. So ship flexibility. The Navy's got to have the ability to maybe not put everything on every hull, but be able to tailor the hull for the mission that it's going to, whether it's mine warfare, whether it's AAW, whether it's surface or any combination. Every hull does not need to necessarily meet every warfare requirement. So I think the technology is there. I believe the knowledge is there. I believe that the system uh, of approval, the system to deliver that is the thing that's holding it up, getting capability to the fleet. Or,
Rick, is there anything else that you would like to share with the Talk a Little, Learn a Lot audience?
yeah, I'm going to go back to something Admiral Wayne Meyer told me, and I've got it on the back of my door here in my office. Don't let the bad guys win. Except it was another B word, but I don't want to say that in public. Um, you can't quit. We then This is the greatest Navy in the world. We do produce. We have the best engineers, the best technicians, the best platforms. The Navy, we the United States, just need to keep moving it forward and never get up. The bad guys are not going to win. We are. Um, and I've been retired since '07. Um, but I think, and I still to this day, which is why I'm engaged with ASNI, believe in our ability to design, build, deliver the greatest systems and ships on the water today. Over.
And so, thank you, Captain Rick White, for taking this time to discuss the Technology, Systems, and Ships Symposium. I hope that we can welcome you back in the future to Talk a Little, Learn a Lot, the podcast of the American Society of Naval Engineers.
Thank you, Steve. And again, I appreciate the opportunity. Um, I want to make sure everybody understands that my thoughts are my opinions. Um, got to give the disclaimer. I do want to encourage the audience, especially the younger people, to get out there and join a technical society of some sort. Um, this provides you the out of chain of command baseline to talk to people, to learn, to grow, how to talk to people, how to learn your profession, and how this does it. I joined ASNI as a lieutenant and retired as a captain, and it has been a significant player in my career. And I encourage everybody to join, whether it's ASNI or SNAMI or whatever. Join something and get out there and talk to your coworkers. Over.
I agree. And I think a good way to start would be to visit the website and then to sign up for the symposium at George Mason University so you can check all that out there.
You got it. Thank you.